Hello friends, this video on continuity and differentiability part 15 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 14. So having understood the four critical derivation of functions, let's take some algebra of derivative, because if you know algebra of derivatives, then you can solve more derivative questions. And in fact, we'll solve a lot of derivative questions to get the hands on that. So there are a couple of algebra of derivatives. The first thing is, if you have a function of this fashion, u plus minus b, if you take the derivative of this, that is nothing but you take the derivative of first, or then you say plus minus derivative of second. We'll take some examples to explain this. Then you have something called product rule. So if you have two functions which are the product, when a function that is product of two functions, you take the derivative of the whole function, that is nothing but take derivative of the first function, multiply the second function, plus take the first function as it is, multiply the second function. Then we have something called quotient rule, where we have the function in the form of u by v. If you want to take derivative of the whole function, that is nothing but you take v square, derivative of the first function into second function, minus first function into derivative of second function. So maybe this is a little boring for you now, but we'll take some examples of this to understand this. Plus, just note here is, there is always u dash v first. In any other formula, in this product rule or quotient rule, u dash is first. So first we take derivative of this. Don't get confused. It is always u dash v minus u v dash by v square. This is correct. It is never v dash u minus v u dash. That is never correct. Correct? So it's always v first, take the derivative of the first guy. If you are saying the product also, or a product rule or quotient rule, we just take the derivative of the first guy first, that is u. So now let's take some example. For the first guy, algebra of derivative, let's take my fx as nothing but 2x square plus 3x. So if you see this guy is nothing but, let's suppose this guy is ux, and this guy is vx. So what I have done, I broke this guy fx into ux, u plus v form. Correct? This is my u and this is my v. Now, if you want to find derivative of the whole thing, that is u plus v, the whole thing derivative is nothing but derivative of u plus derivative of v. So in this case, if ux is nothing but 2x square and vx is nothing but 3x. If you want to find derivative of ux, u dash x is nothing but 2 is the constant, let the constant be there. 2x square is nothing but x to the power n formula. Correct? X to the power n, the derivative becomes what? If my fx is equal to x to the power n, my f dash x is nothing but n x to the power n minus 1. Here n is 2. Correct? Because it is 2 into x square. This 2 was this 2 I took, right? This 2 is this 2. So this becomes 2 into x to the power 2 minus 1. This 2 is here actually. 2 into x to the power 2 minus 1. So that is something but 4x. So my u dash become 4x. Similarly, in this case, my vx is 3x. So my v dash x is nothing but 3 into x to the power 1 actually. This is x to the power 1. So x to the power 1, if you want find derivative, n is equal to 1. So this becomes 1 into x to the power 1 minus 1, that is 0. So this becomes 1. 1 into x to the power 0 is 1. So my v dash x is nothing but 3. My formula says the whole thing derivative is nothing but derivative of first plus derivative of second. So derivative of first is u dash x, that is 4x, plus derivative of second, that is this guy, 3. So this is my answer. This is my derivative of the whole thing. What I've done? I broke this function into two parts, ux, vx. And then what I did was I applied this formula for ux. I solved this for ux. 2x square derivative came out to be 4x. 2x square becomes 2 into x to the power 2 becomes 2 into x to the power 2 minus 1 becomes 4x, and this becomes 3. So that's how it is. So if you are a little confused between derivative, let's take some example. If my fx is equal to x to the power 5, then my f dash x will be nothing but 5, because this guy comes here, into x to the power 5 minus 1, that is 5x to the power 4. Please note, if my fx is equal to x to the power 5, my f dash is nothing but 5x to the power 4. Similarly, my fx is equal to, let's suppose, x to the power 8. So this, my f dash x will be nothing but 8 into x to the power 7. You take this 8 here into x to the power 8 minus 1, that is 7. Similarly, if my fx is equal to x to the power 6, my f dash x will be nothing but, you take 6 down, 6 into x to the power 6 minus 1, that is 6x to the power 5. So please note, this is how we find derivative, and the same thing we did here. So we had this complex question where we had the function as sum of two function, and we individually found a derivative of this, and this added this. So in this same example, let's suppose instead of fx is equal to x to the power 8, this becomes 3x to the power 8. So here also you multiply 3. So this becomes 28x to the power 7. In this case, let's suppose if it is 5x to the power 5, you have 2 multiplied here, 2x to the power 5. Correct? So here also you multiply 2. Because the constant, you can just multiply. Here also, if it is x to the power 6, you have, let's suppose, 5x to the power 6. Then this becomes 5 into 6x to the power 5. That is 30x to the power 5. Correct? Let me take one example for you. So if fx is equal to, let's suppose, 5x to the power 9. So in that case, my f dash x is nothing but, you take 5, you can just leave it here. Now you take derivative of this. X to the power 9 is 9x to the power 8. So this becomes 45x to the power 8. Correct? So if you have some constant, multiply, you just take that constant, and then you try to differentiate the variable part. Here the variable part is x to the power 8. And that's what we have done in this example. Here we have discussed the algebra of derivative. So we discussed u plus v dash is equal to u dash plus v dash, this kind of thing. Let's take the algebra of derivative, the product rule. So here we have u plus v dash is nothing but u dash v plus u v dash. So let's say my fx, I write here, fx is, let's suppose, x cube into x square. I'm just taking, this is nothing but x5. I can directly differentiate this. So this, if you differentiate this guy, my f dash x will come out to be 5 into x to the power 4. Correct? Because x to the power 5 is nothing but 5x to the power 4. But just to explain this example, what I'm doing, I'm breaking this guy into two functions. This is u and this is v. Correct? Now what I'm doing is, I'm using this formula. My uv is nothing but x to the power 3 into x to the power 2. I have to find the derivative of uv dash. This is nothing but derivative of u into v plus u into derivative of v. So what is u? U is x to the power 3. So let's write x to the power, sorry, u is x to the power 3. So you have to find derivative of u first. U is x to the power 3. U dash is nothing but 3x square. That is first set. Similarly, v is x to the power 2. So v dash is nothing but 2x. Second set. Correct? So first you have to find u dash. U dash is what? 3x square. 3x square into v. What is v? X square plus u is x cube into v dash. What is v dash? 2x. This is nothing but 3x to the power 4 plus 2x to the power 4, and this is nothing but 5x to the power 4. So if you see the answer we got here and here same, because we solved the same question using two different approaches. First we solved it directly, and the other we used the product rule. So you will, first thing you should note in maths, and if you have a question you solve by any process, you'll get the same answer. So in this quiz we had this x to the power 5, we used the product rule and we got the same answer. When we directly solve it, we got the same answer. So this was just one application of the product rule, just the basic concept to explain the example. Let's take an example of derivative rule. So let's say my fx is nothing but x cubed by x. I'm taking simple examples. Now this same thing, if you solve directly, this becomes x square, right? And if you want to find f dash x, this is nothing but 2x by normal process. Now let's try to solve the same thing by the quotient rule. So fx is nothing but my u by v, and that is nothing but x cubed by x. So here my u is x cubed and v is x. So my u dash will become 3x square and my v dash will become 1. Correct? So I have all the values. Now if my fx is equal to u by v, my f dash x will be nothing but v square u dash v minus u v dash. Please note, it is u dash v. First u comes and then first derivative of u comes, then derivative of v. So what is u dash? 3x square into v, x, minus u is x cube, v dash is 1 by v square. What is v? X. So it is x into x. So this becomes 3x cube minus x cube by x square. That is 2x cube by x square, and that is 2x. So if you see, you got the same answer, right? So what we have seen here, you solve by any method, you get the same answer. This was just to explain the algebra of derivatives. So here we are using the quotient rule. This rule is called quotient rule, where if you have the function in the form of u by v form, you want to find derivative, that's nothing but u dash v minus u v dash by v. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.